In this video, we are going to learn all about sets. Now, sets are a type of variable in Python that use set theory to mediate all of its actions. Sets are one of those variable types that I feel are underutilized in Python coding. A lot of coders, they maybe don't quite understand how they operate, and so a lot of times, especially beginner coding, they will use lists to do the exact same thing sets can do. So they'll make this really elaborate coding in order to, with multiple lines, to iterate through one list to see if it's in the other list. And the thing is a set can do that very easily in a single line. So I definitely recommend getting very familiar and comfortable working with sets, because they will definitely help you out in your coding. And so what I've done is I've created this cheat sheet to where you can look at all the different behaviors or functions of sets. And I'm going to have this cheat sheet over on the right so that you can always look at it throughout this video. What I have on here on the top left is the Python shell, where we can see the output, and then I have the Python script or the module down here on the bottom left. And what I have are 4 sets that correspond to the different codons, the sets of codons that encode a particular amino acid, like aspartate, glutamate, serine, and tryptophan. Really, it can be just any sets of strings or even any set of numbers that can correspond to a set. Now, the thing about sets is all the items of the sets have to be unique. So, and I mean, it's not going to throw you an error. What it will do is it will just take that list of items and it will compress it down so that it contains only unique items. So, what we'll do here is we will start working with sets. We will create a new set. Now, the way you can create a set is you first use curly brackets to enclose the items, and then you separate each item by a comma. And these items can be either strings or numbers. Now, the first thing we can do is we can copy a set. So we can do, for instance, A equals D. We print A. You'll see that it prints GAC and GAT, which is the components of D. The problem with this is if you were to do A dot add, let's see, TGG, and print A, print D, you will see that when I added TGG, it certainly did add TGG to A. So this is the original A that we copied from D. Then we added TGG, and that got us the new A. Now, but what it also did is it modified D. See, we printed D below here, and now D is modified. So whenever you use the equal sign, whatever you do to one of the sets will also be applied to the other set, the original set. So we don't want to use that. So we want to do that. What we want to do is we want to do A equals D dot copy. Okay, that's going to create a more shallow copy of D, and it's going to assign it the variable A. So you can do, in this case, you can do A dot add TGG, print A, print D. So now I've added TGG to A, but it was not added to D. D still equals the GAT, So whenever you're copying sets, you're probably going to want to use the copy function. Now, you might have noticed that I use I used the string, I inserted the string TGG rather than just doing add W, Because W is a set, you can't just add a set to another set. You have to add the contents of that set. So you have to add each string. When you're using the add, add only adds a single item at a time. Okay. Remove GAT. So A is just a copy of D, so it's going to contain these two components. Then we're going to remove GAT, and so whenever we print it, now you can see that it only contains GAC. So you can add items and you can remove items. Now we can just delete these when we work with D itself. So if I were to type in D dot remove, let's see, let's just do this. D dot, remove GAT. Print. Okay, so it removes GAT. However, if I do something like TGG, so TGG is not inside of D. So whenever I do the remove, what happens is it runs an error. It says a key error. The TGG does not exist in D. Okay, because this component is not within D. What you might want with a set is you might want to remove an item if it exists in that set, but not do anything if it doesn't exist in that set. So in that case, you'll use discard TGG. Then you're going to print D. So in this case, what's going to happen is it's going to remove TGG if it's within D. And since it's not, it just doesn't remove anything. So the remove function, removes an item, but if it doesn't exist, then it's going to throw an error back at you. If you want to remove the item, whether it exists or not, then use the discard item. So that's just some of the, the different mechanics of sets. Now let's start dealing with the Venn diagrams and the different logic or set theory. Okay, so the first thing is union. That's the easiest one to do. So if I were to do, let's say DE equals D dot union E, print E, what you'll see is that now DE is equal to both D and E. So what union does is it combines both of the sets together, like you can see in this diagram over on the right. Now another thing is you could just do, we can just print D union E, or D or E. So that vertical line stands for or, and that's the key that's right above the enter key on the keyboard. So it's below the backspace and above the enter key on your keyboard. Control S, and then you can see that does exactly the same thing. So D dot union E does the same thing as D or E. Okay. The other thing is you could do, let's create a variable. Let's create DE equals D dot union E. Okay. And so now what we have is print DE. And now what I want to do is let's create another one. Let's create ES equals E dot union S. Actually, let's use a shorthand notation. I think it's faster, more slick. Okay. And then we're going to, let's do print. So now, let's print DE, print ES. And what we're going to do is we're going to do DE minus ES. So what this is going to do is the minus finds everything that is in DE that is not in ES. So that's the difference. So everything that's in DE that is not in ES. So if we were to print that, if we were to run this, you could see, so we have, this is the combination of DE, this is the combination of ES, and this is what's in DE that is not in ES, which of course is D, GAT, and GAC, because the shared components is everything within here. Okay. And of course you can do ES minus DE, and that's going to be everything that is in ES but is not in DE. So if you're looking over here, everything that's in the first set that is not in the second set. And here, ES minus DE is everything that's in the second set that's not in the first set. So if I were to do F5, so you can see it returns back to me everything that is in S, because D is unique to DE and S is unique to ES when looking at these. The only thing that's shared is E. Okay. Now another way you can do that is you can do ES dot difference DE. Okay. So that's basically saying ES minus DE. Okay. So let's say, for instance, I want to insert this tryptophan onto DE or onto D. So I don't want to create a new variable. Or a new set. I want to actually modify the original set. The way I can do that is it's similar to the add function. Do d.update w. I'm going to remove these. So d.update w, that's going to modify the original D. So if I were to run that, you can see that it's added tgg to it. Now the difference between add and update takes sets, whereas add takes items within a set. So it takes either strings or numbers, but update will take entire sets. So, and that works throughout the code. So for instance, an update is applied to modify the original one. So for instance, you might have de dot difference update w, or let's see, ES. And what that's going to do is going to modify DE to remove every item that is common between DE and ES. Okay, that's what difference update does. Now update would modify DE so that it's the union of DE and ES. So it contains all of the components of DE and ES. Okay, I know this is getting pretty complicated, so bear with me. Watch different portions over and over to get it to understand it. But again, work with this so that you understand how sets work, because they will be very useful. Now, so we've done difference. We have the next thing would be intersection. So you can do de dot intersection ES. What that's going to do, and then let's just print that out. So the thing that's common between DE and ES is E, which is the GAA and GAC, and so you'll see that that's what it gives back to us, GAA and GC. So it's over here would be A intersection B or B intersection A. It's the same thing, is the common elements of these two sets. You can also shorthand DE and ES. So that will only print what's common between DE and ES. Okay. And the last is the symmetric difference. So DE dot symmetric difference ES is going to be everything that is unique to DE and everything that's unique to ES. So in this case, it would be D and S, because those are the things that are not shared between the two sets. So if I were to run that, you'll see that it has GAT and GAC, and then it has all the things of D and it has all the things of S, but it does not have any of the things of E. That's completely removed. Okay, so that's the symmetric difference, and that's shown here. So it's everything that's unique to A and everything that's unique to B, and it doesn't contain any common element. So now we're going to go through these Boolean statements here, and one of it is disjoint. So if we were to say DE dot is disjoint ES, what that's asking is everything within DE, or is nothing in DE inside ES? So does DE contain all unique components compared to ES? Do they not share any components? And so when we print that out, it's going to be false, because we know that DE shares E with ES. So they can share the GAA and GAC items. So it's not disjoint. They contain common elements over here. However, if we were to do D and S, is D disjoint from S? So here's D and here's S. That's going to be true, because there is no shared component of D and S. They contain unique codons, fortunately, because they're coding amino acids, so we would want them to be disjoint. The other thing is subset. So is subset S. And so what we can do, DE is subset of ES. Of course, that's going to be false, because not everything in DE is inside E of S. That's what a subset is. Now we could create a variable called AA, which is all amino acids, in which we do D or E or S or W. And that's going to create that's going to combine all of these sets. And then whenever we say, is DE a subset of AA, that's going to be true. And that's true for a lot of things. I mean, print D is subset of AA, which is true. So both of those things are true. Now you can do superset. Just modify is AA dot, so is superset of A or of D, and that's going to be true. Of course, so would DE or ES. All of those would be true, because AA is the superset of all of these components. So these are the many different actions of sets. They have an infinite amount of uses in Python. So I highly recommend working with these. Go back over the video, really look into the sets, because they'll be very useful to you.